سيدي راعي المؤتمر الحضور الكريم، حرصا منا على إثراء هذا الملتقى بالخبرات المتميزة من جميع أنحاء العالم، فقد استضفنا كوكبة من المتحدثين المتميزين من دول ومؤسسات متعددة ليتحدث كل منهم في جانب مهم من جوانب موضوع المؤتمر. اسمحوا لنا سيدي بأن نبدأ جلستنا العلمية الأولى التي يقدمها السيد دكتور سيباستيان يوكليلا، رئيس قسم الفحص بمختبر الإمارات للسلامة. التحق السيد سيباستيان بمختبر الإمارات للسلامة كرئيس لقسم فحوص الحريق. جاء تعيينه في هذا المنصب بعد خبرة تزيد عن 10 أعوام في مجال البحث الأكاديمي، وقد عمل في مجالات البحث والتطوير مثل قابلية اشتعال مركبات ألياف الكربون المستخدمة في الطائرات، وتجربة بدائل مقاومة للحريق وصديقة للبيئة، ودراسة تأثير جزيئات النانو على خصائص الاشتعال لمختلف المركبات. كما قدم مدخلات بحثية لمؤشر التعافي للمركز البريطاني لأبحاث البناء. شغل دكتور سيباستيان مناصب متعددة في قطاع الشركات، ولديه خبرة واسعة في مجال الاعتماد وفحوص الحريق في القطاع البحري وهندسة السلامة من الحريق، واختبار واجهات التكسية الخارجية مع تقييم نواتج الحريق بواسطة التحاليل المختلفة، وأنظمة الحماية من الحريق، والتصميم الهندسي والإنشائي لمختبر إطفاء جديد لاختبار نظام الإطفاء بواسطة رذاذ الماء. كان موضوعه لدرجة الدكتوراه في علوم السلامة من الحريق، وركز على انبعاث الدخان وأول أكسيد الكربون أثناء الحرائق في الأماكن المغلقة ذات التهوية المحدودة. نشر لاحقاً العديد من الموضوعات المتعلقة بديناميكيات حرائق الأماكن المغلقة وقابلية الاشتعال للمواد وسميتها، كما شارك في تأليف ورقتين بحثيتين حول اختبار الحريق للتكسية الخارجية. فليتفضل الدكتور سيباستيان إلى المنصة ليتحدث إلينا حول اختلاف معايير الفحص، هل هي مشكلة أم حل؟ Dr. Sebastian, please make your way to the stage.
Good morning, everybody. Mr. General, welcome all the guests who came here. I'm very happy to have the opportunity to talk today about various fire testing standards and to compare them together with you to show what are the benefits, what are the opportunities they can offer. But before I start, I would like to say a few words where I'm coming from. As I was introduced, my name is Sebastian Kleja, and I'm representing Emirates Safety Laboratory, which is first governmental laboratory to focus on fire safety in UAE. And our goal is to offer fire testing, fire-related certification, together with factory audits, but we're going to be heavily involved in research related to fire safety in this region and beyond. We will offer technical trainings and we are open for cooperation. So please feel free to join us on our stand later on during the day. But let's focus now on the main topic. So you are well aware that there are various fire testing standards arising from different backgrounds, and important is if they related to the same product, is that an issue or opportunity. So I would like to compare with you today few of them, and the ultimate goal is to ensure that the fire safety here and beyond is really the highest. So we as Emirates Safety Laboratory can assist you in getting the products on the market, but also we have to ensure that whatever is on the market is meeting the expectation here and further away. So today I will focus mainly on fire resistance and reaction to fire, and for those of you who are not well aware of the difference, I will explain you in few seconds. So fire resistance is one type of fire resistant testing is one type of testing related mainly to building elements. So the aim is that if we have a fire on one side of a building element, it's not propagating for some period of time to the second side. But there are various fire testing laboratories offering this kind of a testing, but you may not be aware that there are factors which influence the result. And just starting with, are we testing in a shallow or a deep furnace? What is the lining of the furnace? So basically, what kind of material is on the wall and floor of the ceiling? How we measure the temperature inside the furnace, and how we measure the temperature of the tested specimen. And finally, how we control the pressure inside the furnace. And all those factors can really affect the results and ultimately can affect the fire safety of a product which is a building element which is tested. So starting with the furnace lining, you may not be aware that this greatly affects the amount of heat the sample is receiving. So do we have the bricks? Do we have the insulating bricks? Or do we have maybe ceramic fiber insulation? Sorry to be too specific, but really I just wanted to show you today there are so many things, and you really need an expertise as a laboratory to differentiate between those things. So the second controlling factor is how we measure the temperature inside. The furnace. Here I'm comparing that according to the old method, ISO 834, which is also very similar to the BS. The amount of heat which the specimen received, it's heavily affected. That was one of the reasons that in Europe plate thermometer was introduced, first to keep the laboratories at the same level in terms of the internal lining, but also in response to the temperature. When we compare the thermocouples between the American approach and the European approach, the curves are basically the same. After 2 hours, it's only 40 degrees difference. There's slightly difference in the location of the sensors, but it's interesting to compare the amount of heat between these test methods. This is not our research. The source is published, so this comes from Canada. So basically, after 10 minutes, the difference is insignificant. But the difference comes how we measure, how these two standards measure the specimen temperature. So the European approach is very specific to look for all weak points. So you can see these numbers show the amount of thermocouples on a roughly similar specimen, which is a vertical node bearing wall. And the European standard tries to assess all the weak points which may develop when this specimen is subjected to fire. We're more generous approach in the other side of the picture. The example of the fire door, again, the European approach is very specific, so you may not see the numbers very clearly on the left side, but it's about 30 thermocouples on double leaf door. So all the weak points are addressed, whereas the approach NFPA UL, it's there's lower number of thermocouples, plus the assessment in the European approach to assess the temperature on the exposed side is for the whole duration of the test, whereas the American approach it's usually for 30 minutes unless the test sponsor requires to continue longer. Again, the pressure measurement inside the furnace, without going too much into details, for example, the fire doors are heavily affected by the measurement of the pressure inside the furnace, and there are small differences, about 4 pascals of the top of specimen between the American and European approach, if we're talking about the positive pressure test with the American approach. For the other vertical specimens, there is no requirements on the pressure in the American approach, which is the case for the European, which also is affecting the results. Finally, you may be well aware about the hose stream in the American approach. You may not be aware that there's a mechanical impact test in the European approach if that is required. And now I would like to focus on interior finish. Why we regulate interior finish? There was a number of very significant fires around the world where the interior finish, so what we have on the walls, on the floor, on the ceiling, was not according to the expectation, and the resulted in very high number of people who lost their lives. Usually these examples reflect to places when lots of people gather, like here today. So we have to regulate interior finish in order that these materials which are inside the room are not contributing to the fire growth. So the aim is, to use a technical term, to avoid flashover. And the definition, the very technical definition here, I'll just give a very simple one. So it's almost simultaneous ignition of most of the materials in the room when the temperature in the upper layer is high enough to create a high heat flux. So we want to avoid that. Now, how we assess the materials for contribution to flashover, or how we control the interior finish materials. On the left, the American approach, which is the predominant approach, so-called Steiner Tunnel, with 3 classes, A, B, C. There is this standard, the first was published by UL in 1950, developed a few years before that date. There is no measurement of amount of heat which is released from that material. Whereas the European approach, which is evolving around so-called SBI, which you see on the right, the whole set of tests was developed up to year 2002, and there is a measurement of heat release rate, which I will explain in few minutes. I will start with the so-called Steiner Tunnel. So the assessment is to develop, to assess what is the flame spread index. That's the American approach in Steiner Tunnel. I will take a very extreme example, which may not happen very often, but the reason to show extreme example is to illustrate some points. So extrude polystyrene foam. In Steiner Tunnel, the result will be class A, which is the best. In 13501, so in European approach, will be class E or F, so close to the weakest one or one before the last one. This foam, when it's inside the room without any thermal barrier, will result in flashover in less than 2 minutes. So clearly, it's a no-go solution for interior lining. And my point here is that based on the study by Dr. Bobrowskaus, which is American study, so there is no bias towards Europe, all these materials in the red circle tested in the Steiner Tunnel will result in flashover less than 1 minute. The rating, because the flame spread index is between 3 and 75, so we're talking class A and B, so-called very good materials, but in real fire, they will contribute to flashover very, very quickly. So basically, not all materials can be tested in the Steiner Tunnel. And those of you who knows this method will answer me that, of course, the recent version of ASTM or UL standard requires about the note to tell to the audience that, sorry, this material, some materials may be not appropriate for Steiner Tunnel. But who should address? There is a note in test report, but is the consultant who is developing a project aware that is this material good from this test or not? The test should give an ultimate answer. Is material safe or not? And in our opinion, this method for some internal linings may give results which are, let's say, confusing. The most, let's say, more advanced approach is to measure heat release rate, basically to measure amount of heat which is evolved during the combustion of a given material. And just to give you an example, for example, small waste basket we result in heat, the peak heat between 20 and 50 kilowatts. So we operate in a scientific units which are comparable to the real sky scenario. When the full involved fire in a bedroom is between 1 and 4 megawatts compared to the car fire, we can reach, the model car can reach even 8 megawatts. So the measurement of the heat release rate, in our opinion, is a step forward. And of course, both European and American standards have a space for more advanced techniques like measurement of heat release rate. In Europe, it's single burning item. In United States, in FPA 286, so-called room corner test, with pass-fail criterion, which is in many building codes now in United States. A single burning item results are classified according to European standard, as given here. As I said before, Steiner Tunnel for many materials results doesn't correlate with flashover. And as I said, we want to avoid flashover as a potential to really life-threatening situation in a room. So now let me explain how heat release rate is linked to and how the new measurement techniques are linked to the potential of the flashover. So on this graph, on the vertical axis, we have the amount of a heat which goes out of the sample during the combustion. On the horizontal axis, we have a time. And when we take our polystyrene, extruded polystyrene, it gives very high peak very soon. So this is red area, really no-go, class E or F. And as you can see, in less than 2 minutes, the flashover in real fire will happen. When we take another material, which slowly goes to the peak, this material goes to class B. There is no potential of flashover. So basically, the contribution from this material to real fire is very, very limited. And then accordingly, we have class C and class D, which falls in between. So the flashover will develop after some period of time. And the final point is that we strongly believe that more advanced measurement techniques will heavily influence the safety level here and beyond. And now I would like, because the facades are really under investigation right now. Let's put it this way. And then I understand that some of other speakers today also will address the Granville Tower investigation in more details. But what I wanted to show to you today, it's that the measurement of amount of heat which comes out of the sample during combustion, which is really a physical phenomenon, can really help during the assessment of different facade behavior. This study, I'm one of the co-authors, was published last year. The main author was Eric Goujon, and during this study, we look at how different facades will behave during the fire, but we measure the heat release rate. So when you look for BRE reports from Granville Tower materials, because of the size of the fire, they had to stop the test just when the fail criteria was reached. What we did here, we took a small-scale sample, 2 meters by 1.2 meters, so let's say 4 square meters sample of a facade, and burn it according to ISO 13785 part 1, which is intermediate scale test, but we measure the amount of heat. And these results are on Fire and Materials website. This is open access, so you're more than welcome to check it. But what I wanted to show you, when you look those images, you don't see really difference. When you look for the temperatures, you don't see much difference because it's intermediate scale test. But you look how much heat is released, measured in a scientific way by oxygen consumption, you clearly see that cladding and type of the insulation material behind is really contributing, making the difference. So here we see that ACM A2 on the mineral wool is behaving twice as good as, for example, ACM just fire retardant cladding with peer insulation. But I want to show you extreme. Now we look at about the Granville Tower. So all the previous results you see on the previous slide, so all these results are completely flat here. We're talking about 300 kilowatts out of 4 square meters sample of a facade. These 3 peaks, you may not see it clearly, but they reach 5 megawatts. So it's the size of car fire, and we're talking about 4 square meters of a facade. So 4 square meters of a, let's say, bad facade will result in a fire of size of a car. Now multiply it by the area you have on the tower block on the high-rise buildings. Just to give some explanation, these 3 results will reach about 5 megawatts. We have the one in the circle, it's ACM on polyurethane. The one with the squares is exactly what you have on the Granville Tower. And the one which is slightly here quicker, it's claddings from the Granville Tower, but the backing material is mineral wool. So you clearly see that with a non-fire retardant polyethylene in the cladding, it doesn't matter if you have the mineral wool behind or not, because this clearly demonstrates that the cladding itself really was the main culprit. Yes, the previous slide showed the insulation also making the difference, but this clearly shows how the measurement of the heat release rate, so how the modern advanced measurements can yield us information which some of the standard fire test reports are not able to answer. And the point here is that when we use the modern techniques, we can really enhance the fire safety here and, of course, beyond. And just a comparison, I said this was 5 megawatt fire as a peak, and as I said, car fire is between modern cars, as checked by BRE a few years ago, can even reach 6-8 megawatts as a peak heat release rate, so the amount of heat released. I'm reaching to my conclusion now. So I show you that there are differences between the fire testing standard for similar building elements or materials or the products. I'm leaving you to reach the conclusions yourself, but the differences were presented. We strongly believe that modern test methods using heat release rate measurement as a scientific approach can be very beneficial for the fire safety here and beyond, because they clearly demonstrate how the materials will behave in a real fire, and that's our goal. The goal is not to have materials just ranked. We want these materials to behave as they should, as they expected during the real fires, which we cannot avoid, at least now. And final point, measurement of heat release rate can really help us to assess the facade behavior, which is not currently the scope of the fire testing standard. And I'm reaching to the end of my presentation, so thank you very much for your time. And I believe that later on during the day, I will be available at our stand, so you would like to have some detailed discussion, myself or rest of our team from Emirates Safety Laboratory are very happy to answer all the questions you may have. Thank you very much. Shukran.